So now on to something important that I want to describe, something called our celestial sphere. Actually, if you printed off PowerPoint slides for this lecture, you don't have this image. I kind of I've just brought it in. But you recognize the Earth, right? And here's the Earth's axis of rotation. There's the North Pole. There's the South Pole. You can kind of see that black back there. Those are stars. Now, the celestial sphere actually is a model. And the thing about scientific models is they are a way of kind of simply looking at things, and you'll see what I mean. So, for instance, the celestial sphere actually assumes or would imagine what the celestial sphere is actually a hollow sphere. So can you kind of see this hollow sphere? And the middle of the hollow sphere is the Earth. And the Earth, and the hollow sphere actually imprinted on the outside or directly on the inside of this hollow sphere are all of the stars we see at night, all the stars in the nighttime sky. So this is to say then, now this isn't the way it really works, but then you could think that the celestial sphere actually then rotates, okay, and that's why our stars move. And honestly, not necessarily the completeness of what this model is, but well, I'm going to talk in the next chapter about a guy named Ptolemy. And Ptolemy, and actually his people before him, kind of about Ptolemy, we were starting to kind of switch and understand that the Earth is a planet that orbits the sun, but they really thought that the stars, okay, orbited the Earth, and the sun orbited the Earth. That's Ptolemy's model, okay? So we know that that's excuse me, that's not the case. But the celestial sphere actually, it's kind of just a way of kind of describing how those 88 constellations of stars can kind of stick together. Okay, so the celestial sphere. Okay, so as we think of the celestial sphere, okay, these first two lines here say what I try to describe. The sphere itself is hollow, and the stars are stuck to that sphere. In the middle of that celestial sphere is the Earth, just spinning each day. Okay, and the Earth spins. As the Earth spins, then we get to see different constellations. So there you go. So keep in mind that the Earth's axis of rotation is tilted, and you're going to see that impact on the celestial sphere here in a minute. And it spins once every 24 hours. And remember that the Earth is orbiting the sun. The Earth is orbiting or revolving about the sun. So here's another celestial sphere. Okay, this one's from your textbook. So a few features of the celestial sphere. Hopefully you can kind of see the similarity in the celestial sphere and this celestial sphere. So in here we, of course, have the Earth, and then we have this hollow sphere. We have the stars imprinted on the celestial sphere. Just some features then to point out. Again, the kind of the orientation of the Earth in this diagram too. You see it, the Earth's axis of rotation. Okay, so this is the North Pole for the Earth, and this is the South Pole for the Earth. So actually, if you take the North Pole and extend it up, okay, you meet this pole itself is called the North Celestial Pole, and similarly, the pole down here is called the South Celestial Pole. There is a celestial equator too. So if we take the Earth's equator and we extend it out, okay, we get the celestial equator. Okay, so that's that kind of light blue sort of arrow circle. Excuse me, right here. That's the celestial equator. Now, kind of drawn at a tilt here is what we call the ecliptic. And actually the term ecliptic I brought up in the previous chapter when I talked about the ecliptic. Let me kind of zoom in so I can halfway these in here. The ecliptic is the plane that the planets or the Earth orbits the sun. Okay, that's the ecliptic. So here, there are some diagrams of this model that actually, the ecliptic then, I know it doesn't work this way, but can you see where this path, these little circles here, are the sun, okay, throughout the course of the year. The sun actually, from this sort of model perspective, appears to move on that line. And that line, not coincidentally, is tilted 23.5 degrees, the same tilt as the Earth's axis of rotation is as from being perpendicular as it orbits the sun. So I know it's. So let's take a look at one more celestial sphere. I love the celestial sphere. Okay, so here we go. Looking at the celestial sphere, this white line right here, this is the celestial equator. We have the celestial poles up here. Up here at this celestial pole, dead center at the top, we have Polaris. Down here, actually, there is no pole star in the southern hemisphere. Okay, and then we have the dot, 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 dot. That's the path that the sun makes throughout the course of the year against the background stars, right? Actually, if you're into astrology, this path that the sun makes throughout the year against the background stars, that gives us our constellations of the zodiac. So there you go. Who says we're not going to talk astrology in this class? So this up here just kind of reminds you that even though we see a set of stars, for instance, these, looks like this might be, stars of Perseus. Here are 4 major stars of Perseus. Even though we see them kind of appear to be flat against the celestial sphere, they definitely are broken up. There are definitely different distances from us. So again, you see that 88. Don't forget. Okay, how many constellations are there on the celestial sphere? There are 88.